This is a video on balancing chemical equations. So for Year 9 Science, this is part of the syllabus. And this also pops up in Year 11 Chemistry, Year 12 Chemistry. I get asked this a lot by students, sir, what's the best way to tackle balancing chemical equations? There's really different ways to do it. It's not something you can teach someone per se. It's really just application. So it's really just doing examples, right? So I'll start off with a very simple one. H2 plus O2 makes H2O. So a chemical equation is just another way of writing a word equation. Okay, so in this case, H sub 2, that's hydrogen. That's a hydrogen molecule. Okay, I'll draw two little spheres here connected by a line. That's a bond. O2, that's an oxygen molecule. Okay, two oxygen atoms joined together. H2O, that's a water molecule. Okay, H2O is water. So I've got one oxygen and two hydrogen linked to it like a Mickey Mouse head. So plus, I'm just adding them together. And this arrow means makes. Okay, makes or forms. And a chemical equation is much like a mathematical equation. It's all about balance. So think of a seesaw. The left-hand side and right-hand side have to be equal. Why is that the case? Well, there's a law of the universe called the conservation of mass. Okay, you cannot make or destroy mass. You can only have mass transferred, right? Or in this context, atoms can only rearrange themselves, okay, in a chemical reaction. Okay, so as you can see on the left-hand side here, there's hydrogen and oxygen. They're the only two elements. On the right-hand side, there's hydrogen and oxygen as well. Okay, you're not getting gold or anything else here. It's the exact same thing as the left-hand side. Okay, so you need to have both left-hand side and right-hand side balanced. Okay, well, in this case, it's really all about counting the number of atoms. So the left-hand side, let's count how many atoms there are. H2, there's two hydrogens, so let's take an inventory. The first step in balancing a chemical equation is to take an inventory, okay, to make a list. So let's draw a line here, separating the left-hand side and the right-hand side. What elements are present? Well, H, if you just look at your periodic table, H is hydrogen. There's two. There's two of them because H sub 2 means there's two hydrogen atoms. Oxygen, there's two as well. That's the left-hand side. What about the right-hand side? Well, we've got to have the same elements, okay? H and O. There's two hydrogen. Now, here's where the issue comes. There's only one oxygen atom. What do we do here? Well, the rules of balancing chemical equations state that you can only add coefficients, numbers, at the front of elements or compounds. You can't put numbers here. Let's say where the 2 is, you can't put another 2. It doesn't work. Okay. So we need to find what these coefficients are. Okay, we're basically adding numbers, right? So hydrogen is fine, tick, tick. What about the oxygen now? We can only multiply, right, the number of atoms present. So in this case, oxygen, how do we turn that into 2? How do we turn this 1 into 2? Well, we simply multiply by 2. Okay, that gives us 2. Where do we put this 2? We'll put this 2, we can only put it, remember, at the front, okay, of this compound, which is H2O here. So the 2 goes out here. Best thing to do is put parentheses, put brackets around H2O because that's one compound, right? H2 and O are not separate, they're together in this case. So that solves that, tick, tick, but we've got another problem. Hydrogen now becomes 4 because you've got 2 times H2, which is 2 times, so 2 hydrogen molecules, okay? So that now becomes 4. Let's cross that out and put a 4 here. What do we need to do to this? Well, to go from 2 to 4, you need to times it by 2, so you get 4 here. So you put a 2 out the front here, okay? Because 2 times 2 is 4, right? And so that's how you balance a chemical equation. Okay, it's really just left-hand side, right-hand side, making sure you got the same number of atoms, right? So that's an example there. Let's do another one. Let's do ammonia formation. So ammonia is nitrogen plus hydrogen, and you get NH3. NH3 is ammonia. Ammonia is found in your household cleaning products, right? So first things first, let's take an inventory. Well, there's nitrogen and there's hydrogen. Okay, there's two elements that we can see on the left-hand side. Same thing on the right-hand side. Let's now count. Well, there's two nitrogen atoms, that's two. And there's two hydrogen atoms, that's two. Right-hand side, there's one nitrogen atom. And there's three hydrogen atoms. What do we do? Well, we have an issue here. There's one nitrogen on the right-hand side. Let's turn that into two by multiplying by two. We can only multiply. Okay, we can't add or subtract or anything, just multiply. That gives us two. So let's put a two out the front here. That's the coefficient of the ammonia molecule. I'll put parentheses around that. So that's problem solved there. However, the hydrogen is now 6, okay? Because H3, that's 3 hydrogen atoms linked together. 3 times 2, that's 6. Okay, so that now becomes 6. So what do we do to the left-hand side now? Well, to go from 2 to 6, we need to multiply by 3. Okay, so now we put the coefficient 3 in front of the H2. Okay, and that's how you balance this chemical equation. And I should also mention in the previous example, this is basically like you can think of it as like the minimum case in terms of making water. You can only get a minimum of 2 water molecules. Okay, in the lab, if you had hydrogen and oxygen, they will combine in these ratios, and the minimum amount of water you can form is 2 water molecules. Okay, let's do another example. Let's do methane, CH4, plus oxygen, O2. That'll make carbon dioxide and water. Okay, this is an example of combustion. Okay, methane found in natural gas. Okay, that ignites. Let's say you get a flame, ignite the methane, and you will get carbon dioxide and water. Okay, first step. Let's take an inventory. Let's start from left to right here. So carbon is the first element we can see, followed by hydrogen, H, and then oxygen. Similarly, on the right-hand side, carbon, hydrogen, and oxygen. It's best to put them in the right order, okay? Let's keep track of things, just makes it easier. Carbon, there's 1. Hydrogen, there's 4. Oxygen, there's 2. Right-hand side, carbon, there's 1. Hydrogen, there's 2. Oxygen, there's 3. What do we do here? Well, carbons are fine, tick, tick. Hydrogens, we need to turn this 2 here into a 4. Multiply by 2, we get 4. So we'll put a 2 out the front here. Okay, it's not 4, it's 2 because 2 times 2 is 4. Now we have an issue with oxygen. We've now got 4 oxygen because we've got O2 here and we've got 2 times O, which is 2. So 2 plus 2 is 4. Hydrogens are fine. What do we do here on the left-hand side? We turn this into a 4 by multiplying by 2. 4, so we put a 2 at the front. And there we have it. That's the balanced chemical equation. Sometimes in the exams they might trick you. I'll show you this example here. Let's suppose you've got hydrochloric acid, HCl, plus sodium hydroxide. So this is a neutralization reaction, okay? Acid-base reaction. Gives you a salt, sodium chloride plus water, H2O. Let's take an inventory. Hydrogen, I can see chlorine, I can see sodium, I can see oxygen. Same thing on the right-hand side, hydrogen, chlorine, sodium, oxygen. Let's count hydrogen on the left-hand side. There's 2. Chlorine, there's 1. Sodium, there's 1. Oxygen, there's 1. Right-hand side, hydrogen, there's 2. Chlorine, there's 1. Sodium, there's 1. And oxygen, there's 1. Tick, 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 tick. This is balanced, okay? So sometimes they'll trick you. Don't freak out. It's just, that just means that it's balanced, right? You can double check that. And that's how you balance chemical equations.